Hey y'all, it's Mrs. Saunders with Caffeinate Math, and today's lesson is brought to you by San Antonio, Texas. Hello, San Antonio. Today I get to introduce you to rational numbers. And when I say rational numbers, what I'm really introducing you to is the world of fractions. And to really appreciate rational numbers, or fractions, we need to take a quick trip back to Egypt, like ancient Egypt. So we first see fractions appear on the pages of history back around 1800 BC. But they didn't look like this. They looked more like that. Seriously? How is that a fraction? But it's pretty cool, and I'll show you how it worked. So let's see what's on the agenda for today. We'll learn a quick history of rational numbers, the definition of rational numbers, and the rules for rational numbers. Now, let's go see how that I thing worked. Well, to be honest, all of the Egyptian numbers were kind of wonky because they used pictures, not the numbers we use today. So it makes sense that they use pictures to represent fractions as well. So let's take a closer look at this I thing. It's called the Eye of Horus. Horus was one of the ancient Egyptian gods. And each part of this eye came to represent a fraction. For example, this part represented 1/2, the pupil was 1/4, the eyebrow was 1/8, and they worked down to 1/64. Can you imagine trying to do math problems like that? Yeah, I have no idea. Okay, let's fast forward now to India, about 2,400 years later, and we meet this dude, Brahmagupta. He's the one that began the convention of writing fractions as one number on top of the other. But it was still confusing a bit because, well, how do you know they go together? Fast forward another 600 years, and the Arabs added this line in between the numbers. It took 3,000 years to get from the Eye of Horus to this. And this is what we're focusing on today. Are you ready? Let's go. First, let's define rational numbers. A rational number is any number that can be written in the form of a over b, as long as a and b are both integers and b does not equal 0. So let's break that down a bit. The first part of the definition says that a rational number is any number that can be written as a over b. And remember, a is the numerator and b is the denominator. The second part of the definition is that a and b both have to be integers. But what's an integer? The integers are the counting numbers, 0, and the negatives of the counting numbers. So for our purposes, we can just sum it up and say no decimals on the top or bottom. And then the last part of the definition is that b does not equal 0. Okay, easy enough. The denominator cannot be 0. So with all that in mind, let's try out a few examples. I'll put up a number, and you try to figure out if it's a valid rational number. So let's see, 4 over 5. Yep, that works. How about 57 over 9? Yeah, sure, it's okay if the top number is bigger. What about 6.5 over 2? No, there's a decimal there. How about negative 19 over 29? Sure, nothing against negative numbers. How about 0 over 33? Sure. And one more. How about 17 over 0? No. Remember, the denominator cannot be 0. Okay, let's try a few more. And warning, it's going to get more complicated. Here we go. This time, I'm going to ask you to verify that a number is a rational number by writing it as a over b. So like this, the first one is 51. It's not in the form of a over b right now, but could it be? Well, if we put it over 1, 51 divided by 1 is still 51. So it's the same value, but now we can see it in the form of a over b. We could generalize that rule to look like this. A equals a over 1. What about 6 2/3? Now I see a fraction there, but it's got that whole number next to it. So we just need to change it from a mixed numeral into an improper fraction. So let's see, 6 times 3 is 18, plus 2 is 20. Okay, 20 over 3. Still the same number, but now written as a over b. What about 0.9? Now this one is a bit trickier. Think of the decimal place values. What place value is that in? It's in the tenths place, so that's 9/10. And there we go, a over b. If you see a decimal, just use the place values to turn it into a fraction. Okay, try -78. Let's just put it over 1, like we did before with 51. The negative doesn't change anything. And one more, 0.67. Okay, that's a decimal again, so if we use decimal place values, we know that 0.67 is 67 hundredths. All right, and we'll stop there for now. We've come a long way today. I mean, we took a trip back to ancient Egypt, India, and Arabia, and that was the history of rational numbers. We talked about the definition of rational numbers and worked a lot with the rules of rational numbers. Not bad for a day's work. And now, I'm out of here.